Okay, we're going to look now how we can find our latitude following an observation of Polaris. In this example, Polaris was observed during morning twilight. We're given the date, the DR position, the sextant altitude, index error, height of eye, and the time the chronometer showed with the error. So the first thing we need to do is find an approximate local mean time for the morning twilight. So we'll go in the day in question, the 4th of July. We have the 4th of July, and we simply go down to the times of twilight with our latitude of 44 degrees north, 43, 44, and we'd see that the approximate LMT is 0400 on the 4th. What we then need to apply is the longitude to that, and we've got a longitude of 149 degrees 38 east. So we go into the back of the book where we have conversion of arc into time, and we look up 149 38. 149 956 plus 230, that's 958. So we find that we've got 9 hours 58 minutes to apply to the local mean time. Now, longitude is east, therefore Greenwich is least. So that means we have to subtract that from the time of the 4th at 0400. So this now takes us into the 3rd at 1802. So we're now into the 3rd of July. If we look at our chronometer says 6 hours 0146. Well, if we're at 18 hours 02, then we need to change that 6 hours to 18. So in other words, it's 12 hours out. So our chronometer will read 18:0146. 5 minutes 29 seconds fast, so we need to subtract that from the chronometer because it's running fast, and then that tells us that the correct time is 17 hours 56 minutes 17 seconds on the 3rd. So now we've gone into the 3rd of July. What we do then, we go into the tables on the 3rd of July and we look up Aries, and we look up at the time of 17 hours. So we go to 17 hours and we find it's 176.36.2. We then go into the back section under the increments and we look up 56 minutes 17 seconds for Aries, and we find the increments of 14 degrees 06.6. So we now have a GHA of Aries of 190.42.8. We then apply the longitude east, Greenwich is least, therefore we have to add those two values together, and that gives us an LHA of Aries of 340 degrees 20.8. So now we've got one of the values that we require, LHA of Aries. The next thing we need to find out now, we need to look at our sextant altitude. So we need to find our altitude. Given 44 degrees 31, the index error is 0.5 off the arc. Now whenever an index error is off, you always add it. So this is now 4431.5. We're told that our dip, our height of eye, is 17.4 metres. So dip relates to a height of eye 17.4 metres. So we go in the tables, the dip table, and we go along to find the nearest to 17.4, and then we read the value directly above the value. So 17.4 on the left, the value of the correction is minus 7.3. So we subtract the 7.3, and that gives us an apparent altitude, and then we now need to apply the main correction to the apparent altitude of 44 degrees 24.2. So we go into the tables under the stars and planets, because we're dealing with Polaris, the star Polaris, and we need to go down at 44 degrees 24.2. So we come down to 24.2, and we can see it's between 42 and 45, and our correction is minus 1.0. So we apply that correction of minus 1, and that gives us a true altitude of 44 degrees 23.2, which we've written over here. What we need to do with this value now is apply the A corrections, A0, A1 and A2, which we find under Polaris. So if we go towards the back of the table and we find the values for Polaris, and you'll see Polaris pole star tables, and we've got the LHA written along the top, and we need to find an LHA of 340 degrees 20.8. So we can find here 340 degrees, so that's 340, 341, 342, 343, 344 down to 349 there and 350. So we want between 340 and 341. 340 is 28.5 and 341 is 27.8. So we interpolate between those two and we would come up with a value of 28.3 after interpolation. So we'd write 28.3. Now all these are added, these corrections. Then we go to A1 under the LHA values and we go down to with our latitude of 43 degrees and we find between 40 and 45 and we see that correction is 0.6. Then we go down to A2 and we look at the month, and our month is July, and then we write our correction there, which is 0.3. So we've got a correction of 0.6 and 0.3. So we add all those together and that gives us a true altitude of 44 degrees 52.4. We always subtract 1 degrees. As soon as you get that value, subtract 1 degree and that gives you a latitude of 43 degrees 52.4. So that is the latitude of the vessel. If we want to find the azimuth, the true bearing, again we go down at the values of the LHA, down to the bottom section where it says azimuth. And again we go across with our latitude between 40 and 50. So our latitude is between 40 and 50 here, and the LHA is down, and we find it's between 0.8 and 1, so we call it 0.9. So our true azimuth or true bearing is 0.9 degrees true, or 1 degrees. So if we wanted to draw our position line, then that would be 90 degrees to that, so the position line would be 091271. Now also, you can calculate a compass error. If we'd taken a compass bearing, for example, say we'd taken a compass bearing of Polaris at the same time and got 010 degrees compass, we've just calculated that our true value, the true compass, would be 1 degrees. So true is 001 degrees. So that would tell us that our total compass error is 9 degrees, and because compass is best, error is west, so our compass error is 9 degrees west. Had we also known our variation, say our variation had been 6 degrees west, we can also find the deviation for the vessel. And we know that the combination of deviation and variation equal compass error. As long as we know 2 of these 3 values, we can find the third. We know our compass error is 9 degrees west. We've said our variation is 6 degrees west. Therefore, when we look at that, we must know that our deviation is 3 degrees west, because those 2 there, the combination of those 2 must equal that. So although that isn't in the question, had you been given the compass bearing of Polaris as well as the sextant altitude, you could have calculated the compass error, and if you'd been given the variation, you could also have calculated the deviation. Now, if you hadn't been given the latitude in this question, you would have simply used the altitude of the vessel, because the sextant altitude is going to be very near to what the latitude is anyway. So had you not been given the latitude, you could have still found it, because you'd have gone in the tables with the latitude value appropriate to the sextant altitude.